The goal of this video is to look at how to do multiple correspondence analysis when the data has missing values. We're going to use the MIS-MDA and FactorMiner R packages to show you how to do this. We're going to use a dataset that is part of the MIS-MDA R package. It's the one called VNF. This dataset is a survey on 1,232 people who answered 14 questions. In this dataset, there are missing data. Not all individuals replied to all questions. Some questions even have a lot of missing answers. So how can we deal with this? To begin with, we could simply use the MCA function in FactorMiner and see what happens. So we run MCA on the VNF dataset. Out comes the plot with the MCA variables. If you need a reminder on what the MCA output means, feel free to go back and have a look at the MCA video. Okay, so we have the variables plot, the individuals plot, and the categories plot. On the categories plot, what do we see? We see some categories with point NA. In fact, each time that there was at least one missing value for a variable, a new category was created called NA, and all the individuals with a missing value for that variable were put into the NA category. We can see in the first plane of the MCA that there is a grouping of certain NA categories. What this means is that, for example, individuals who didn't reply to questions 8.1 or 8.2 also didn't reply to the questions 8.3 or question 9 or question 7, for example. What we are seeing here is the structure of the missing data, that is, for which variables are the unanswered questions related. These unanswered questions rather characterize the first dimension, and there is another group of them that instead characterizes the second dimension. The question Q30, Q29, and Q40. This graph is of interest when it comes to visualizing the relationships between the missing data entries, but not so much for visualizing the information contained in the survey answers. The actual information contained in the replies doesn't even appear on the first two axes. Sure, it may be found on subsequent axes, but still disrupted by the missing data. This doesn't mean that the MCA is not of interest to us. It's interesting to see what the plots look like when the missing data isn't treated in any way, but if we want to focus on the observed data, we kind of want to just be able to look at this data and not what it looks like when disrupted by missing data. For this, we are going to use the MIS-MDA library. To begin with, we have to estimate the number of components needed to impute the data. This can be done with the estimNCP-MCA function in MIS-MDA. Here, the function tells us that we need 5 components. Once we have chosen the number of components, we can fill in the missing data, impute the missing entries using the ImputeMCA function on the VNF dataset. So here we are with the imputed dataset. We can now see the results. In complete, there are 2 things, an object called tab.dish and another called completeOps. We can visualize tab.dish. It's the disjunctive table after imputation. In fact, in MCA, each qualitative variable is turned into as many indicator variables as there are categories. So therefore, we get this disjunctive table, and thus, in each column, we have the value 0 or 1. 0 if the category is not taken, and 1 if it is. That's for the observed data. As for the data that were missing, well, they have been imputed, but not with zeros and ones, but with real values which can be interpreted as the degree to which the individual belongs to that category. For example, we can say that for this variable, individual 1 and 2 didn't reply, but individual 1 would have chosen the first category, whereas individual 2 would have chosen the second. So if I'm now going to directly impute the qualitative variable, I'd input the first individual with the first category and the second individual with the second category. We can now run the MCA. we're going to run it on the VNF table, but signaling that we want to use the disjunctive data table that we've just imputed. So we run the MCA, and this outputs the variables plot, the individuals plot, and the observed categories plot. This time, there are no missing data, so we're going to be able to visualize much better the links that may exist between the categories taken by each individual. In conclusion, to do MCA with missing data, we suggest that you do the following. First, visualize where the missing data are by creating a missing data category, which is anyway done by default by the MCA function in FactorMiner, as it is in most software packages. Then, if you want to visualize the actual observed data, you have to impute the missing data and work with the imputed disjunctive table. Again, this means running the MCA function from FactorMiner. The data is imputed in such a way that the imputed values have no influence on the axis construction, so the axes constructed here are done so based only on the observed data. This is important because we only want to visualize the information contained in the observed data. However, be careful because the percentages of inertia associated with the axes will be a little overestimated because we imputed the missing data using only the first MCA dimensions. This will exaggerate the structure that can be seen in the first MCA plane. The plot is helpful for seeing relationships, but the percentages of inertia should be interpreted with caution. If there are not many missing data, the percentages of inertia will be slightly overestimated, but if there are a lot, they could be highly overestimated.